Elon Musk just revealed a new Tesla EV motor that feels less like a routine product update and more like a direct challenge to the foundations of the modern car business. The moment carries weight because the electric motor sits at the very center of the EV revolution. Batteries get most of the attention, software gets the headlines, and autonomous driving often takes over the conversation. But the motor is where electricity becomes motion, where design promises are converted into real-world acceleration, efficiency, durability, and cost. If Tesla has truly introduced a motor that dramatically changes the balance between performance, price, manufacturing complexity, and energy use, then this is not simply about one new component. It is about a possible redefinition of what an electric vehicle can be, how cheaply it can be built, and how quickly legacy car makers could find themselves cornered. Before we start, smash the like and subscribe buttons for more updates. What makes the reveal so explosive is that most people still think of EV motors as a solved problem. The common assumption is that the real battle is happening in batteries, charging networks, and software ecosystems, while motors are merely mature pieces of engineering that all serious automakers more or less understand. That assumption is exactly why a major breakthrough in motor design would hit the industry so hard. When an area is assumed to be stable, disruption there is especially dangerous. Companies budget around it, they design factories around it, they structure supplier contracts around it, they hire engineering teams around it, they commit billions on the belief that the core architecture is settled. If Tesla has just shown that the heart of the EV powertrain can still be radically improved, then many current strategies may instantly look outdated. The importance of the event begins with the brutal economics of electric vehicle production. An EV motor is not just a propulsion unit, it is one of the key determinants of efficiency, heat management, driving range, packaging, service needs, and production cost. A superior motor can reduce the amount of energy wasted as heat, improve acceleration without increasing battery size, shrink the physical space needed in the vehicle, simplify cooling, and lower the total system burden on everything from wiring to control electronics. That means the motor can quietly transform the entire vehicle without being the most visible feature. If Tesla has pushed motor efficiency higher while cutting complexity and material cost, then it has attacked several of the biggest pain points in EV manufacturing at once. That is why the reveal has such deep implications. The car industry does not merely compete on who can build an electric car. It competes on who can build one profitably, at scale, while preserving performance, maintaining reliability, and controlling costs across volatile supply chains. A motor breakthrough touches every one of those pressures. It changes how much copper is needed, how magnets are sourced, how thermal systems are designed, how inverters are calibrated, how vehicle platforms are packaged, how battery packs are sized, and how assembly lines are configured. When one component has that many downstream effects, a major leap in that component can ripple through the entire industrial model. There is also the Tesla factor, which makes the moment even more intense. Tesla is not seen as a conventional car company that occasionally announces technical refinements. It is seen as a company willing to take manufacturing risks, challenge industry assumptions, and build around first principles logic rather than inherited conventions. So when Musk reveals a new motor, the industry does not hear a normal launch. It hears a possible warning shot. Tesla's reputation for all its volatility has been built on repeatedly forcing the rest of the market to react. The company does not always win because of marketing alone. It often wins by compressing the time competitors have to adapt. The real threat is not that other automakers fail to understand the new motor. The threat is that they understand it immediately and still cannot respond fast enough. At the center of the excitement is the idea that motor innovation can unlock a new level of efficiency without demanding sacrifices elsewhere. In the EV world, efficiency is king because it compounds. A slightly more efficient motor does not just save a little energy. It can allow a smaller battery for the same range, or more range from the same pack, or stronger performance without a massive penalty, or lower cooling demands under sustained load. It can also improve towing behavior, high-speed consistency, and long-term durability. Efficiency is not a narrow laboratory metric. It shapes the character of the vehicle, the economics of ownership, and the viability of mass-market pricing. If Tesla has meaningfully improved motor efficiency, then the company may have opened a path to cheaper EVs that still feel superior on the road. That is a nightmare scenario for competitors because it attacks them from both ends of the market. Premium brands rely on performance, refinement, and engineering prestige. Mass-market brands rely on affordability and production scale. A motor that is both powerful and cheaper to manufacture squeezes both categories at once. Luxury brands can no longer lean on superior driving dynamics if Tesla can deliver more speed, smoother power delivery, and better energy use in a cleaner package. Budget brands cannot rely on price if Tesla can use a more efficient motor to reduce total vehicle cost while preserving the appeal that draws buyers in the first place. When a single technological step starts collapsing the old separation between premium and mainstream, the whole segmentation logic of the auto industry begins to weaken. Another reason this event feels so consequential is that motors are tightly linked to raw material politics. One of the biggest tensions in EV production has been dependence on specialized materials, especially those tied to complex global supply chains. Any motor design that reduces reliance on expensive or strategically sensitive materials would be enormously important. It would not just lower cost, it would reduce geopolitical exposure, supplier concentration, and vulnerability to pricing shocks. The industry has spent years talking about battery minerals, but motor materials matter as well. If Tesla has found a way to reduce or optimize the use of rare materials in a high-performance motor, then it has achieved something every serious automaker wants, but few can execute at scale. That possibility alone would explain why the reveal lands with such force. It suggests Tesla may not simply be improving a motor in the narrow sense of torque output or rotational speed. It may be redefining the industrial equation behind the motor. That is the kind of innovation that terrifies incumbents because it is not copied just by benchmarking the finished product. A company can tear down a competitor's vehicle and inspect the hardware, but that does not immediately reveal the manufacturing know-how, supplier integration, process tolerances, software calibration methods, and factory discipline required to reproduce it. In other words, even if the design principle becomes visible, the execution moat may remain enormous. Then there is the issue of power density, one of the most powerful but underappreciated advantages in vehicle engineering. A motor that delivers more output for less size and weight can reshape the layout of the entire car. It can free up interior space, improve crash structure options, allow different suspension packaging, and make dual motor or performance variants more practical without dramatic penalties. Smaller, lighter, more powerful motors give designers and engineers room to rethink vehicle architecture. That matters because EVs are still evolving. The industry has not reached a permanent template for the ideal electric vehicle. If Tesla now has a motor that gives it more flexibility in platform design, then it can move faster across multiple body styles and price categories. This is where the implications begin to spread beyond Tesla itself. A genuinely superior EV motor would pressure suppliers across the ecosystem. Companies that manufacture components for legacy motor architectures could suddenly face shrinking relevance. Firms that have invested heavily in one type of traction motor may discover that future contracts depend on a different approach. Tooling choices, casting methods, cooling solutions, and electronic control strategies could all come under pressure. A disruptive motor is not just a better product. It can trigger a supply chain reorganization. And supply chains do not pivot overnight. They are built through years of contracts, certifications, testing programs, and production commitments. That lag is exactly what gives a breakthrough its destructive power. The reveal also intensifies the battle over who truly owns the identity of the electric vehicle. For years, many traditional automakers have tried to present EVs as inevitable extensions of their existing brand strengths. They speak about heritage, craftsmanship, dealership support, and decades of engineering experience. But a radical motor reveal from Tesla re-centers the conversation on technical leadership rather than legacy credibility. It reminds the market that in a period of platform transition, old strengths can become secondary if a new entrant controls the most important enabling technologies. If Tesla can convince buyers, investors, and competitors that its motors are meaningfully ahead, then it regains the aura of being the company defining the future rather than just participating in it. There's also a deeper symbolic dimension to this event. In the age of EV hype, many announcements focus on interfaces. Screens, subscriptions, styling tweaks, or software features that look futuristic but do not fundamentally alter the engineering reality of the car. A motor reveal cuts through that noise. It is not decorative, it is not cosmetic. It is not just a new trim package disguised as innovation. It is the hard mechanical electrical core of the machine. That gives the moment a different level of seriousness. Even those skeptical of Tesla's showmanship tend to pay closer attention when the subject is a major powertrain advancement, because powertrain changes cannot be sustained by branding alone. They have to work under intense thermal loads, in all climates, under repeated use, at scale, with warranty implications attached. If the motor Musk revealed combines high output with better heat resistance, that would be especially significant. Thermal performance is one of the hidden battlegrounds in EV engineering. It affects sustained acceleration, repeated launches, highway cruising under load, hill climbing, towing, and battery interaction. A motor that can stay efficient and powerful under stress gives the vehicle consistency, not just peak numbers. That is crucial because many performance claims look impressive in ideal conditions, but become less meaningful when temperatures climb and the system protects itself. A motor with superior thermal management would not merely make Teslas faster, it would make them more dependable in demanding real-world conditions, which is far more important in the long run. That kind of durability advantage would carry enormous commercial meaning. Consumers may be dazzled by acceleration times, but fleet operators, commercial users, and practical buyers care about repeatability and operating cost. A motor that resists heat, wear, and performance degradation can expand Tesla's appeal far beyond tech enthusiasts. It can become a weapon in delivery fleets, ride-hailing operations, commercial transport categories, and high-mileage ownership cases. This is where a motor breakthrough stops being a niche engineering story and becomes an industry-wide threat. The car business is not only about selling to excited early adopters, it is about dominating the boring, large-volume use cases where costs and reliability decide everything. The reveal would also sharpen attention on Tesla's manufacturing philosophy. Tesla has long tried to reduce part counts, simplify assembly, and treat the car less as a collection of separate systems and more as an integrated product engineered from the ground up. A new motor fits directly into that philosophy. If the design is easier to build, easier to integrate, or easier to automate in production, then Tesla gains much more than a technical edge on paper. It gains manufacturing momentum. That is often what separates interesting prototypes from industry-changing products. The auto graveyard is full of clever engineering that never translated into scalable production. What makes a Tesla motor reveal so disruptive is the assumption that Tesla intends not only to show it, but to industrialize it aggressively. This is also why legacy car makers face a uniquely difficult response problem. They are not starting from a blank sheet. They are burdened by existing platforms, plant layouts, supplier relations, union structures, internal politics, and model roadmaps that were frozen years in advance. Even if executives instantly recognize the importance of Tesla's motor, they may not be able to react without writing off previous investments or delaying current launches. That is the trap. Disruption does not destroy an industry simply because the incumbents are unaware. It destroys them because they are too committed to earlier decisions to pivot in time. A motor breakthrough lands hardest when rivals are already mid-transition and financially exposed. And this transition is already brutal. Car makers around the world are trying to manage the decline of combustion engines while financing the rise of electric platforms. They are balancing regulatory pressure, consumer uncertainty, charging infrastructure challenges, battery costs, and market fragmentation. In such an environment, the last thing they need is another layer of technological instability. Musk revealing a new motor is like opening a fresh front in a war that many automakers are already struggling to survive. It means the path to competitiveness may be moving again, just as they thought they had found it. Another powerful implication lies in design simplification. Modern vehicles are often burdened by hidden complexity that customers never see but manufacturers pay for at every stage. Complex wiring, difficult assembly sequences, expensive cooling loops, intricate mounting requirements, and fragile supply dependencies all raise cost and slow scaling. If Tesla's new motor eliminates steps, reduces components, or integrates functions previously handled by separate systems, then the innovation is even more dangerous than a pure efficiency gain. Simplicity is a weapon. It reduces labor time, shrinks failure points, improves repeatability, and accelerates production learning curves. A simpler motor system can lower total vehicle cost in ways that exceed the motor itself. That has direct consequences for pricing strategy. The EV market remains under constant pressure over affordability. Consumers want longer range, faster charging, better performance, and lower prices all at once. Most automakers struggle to satisfy all of those demands because improving one dimension usually strains another. A major motor improvement changes that math. If the drivetrain becomes more efficient and less costly, then manufacturers can make different trade-offs. Tesla could decide to keep prices steady and expand margins, or cut prices and squeeze competitors, or add more performance at the same price, or bring advanced EV features to lower-cost segments. The reveal therefore matters not just because of the motor itself, but because it broadens Tesla's strategic options. And when Tesla gains strategic flexibility, the rest of the industry loses it. Rival firms operating with thinner margins or slower development cycles cannot easily match rapid shifts in price and specification. They may have to choose between losing market share, sacrificing profitability, or delaying future investments. That is the kind of pressure that reshapes entire corporate strategies. It can force partnerships, cancellations, platform consolidations, and internal restructuring. A breakthrough motor may sound like a narrow engineering event, but the implications extend all the way up to boardroom decisions and capital allocation. There is also an emotional layer to the reveal that should not be ignored. The car industry is built as much on narrative as on engineering. Buyers want to believe they are purchasing into the future, not just acquiring transport. Investors want to back the company with momentum, not the one reacting defensively. Engineers want to work where the hardest problems are being solved. A dramatic Tesla motor reveal feeds all three instincts. It creates a sense that the center of gravity has shifted again toward the company willing to rethink fundamentals. That psychological effect can be almost as powerful as the hardware itself. Confidence attracts talent, capital, and attention. Fear drives hesitation. Momentum in technology markets often compounds before the full commercial consequences are visible. For traditional automakers, that narrative problem is severe because many of them have spent years promising that they are closing the gap with Tesla. They have unveiled sleek EV concepts, launched new electric sub-brands, and framed the competition as a matter of scale and polish rather than raw innovation. A motor reveal of this magnitude undermines that story. It suggests the gap was not static. It was widening in a domain that matters deeply. It tells the market that catching up on yesterday's EV formula may not be enough because Tesla is already moving the formula itself. The implications also stretch into the future of vehicle categories that have been harder to electrify convincingly. Higher performance motors with better efficiency and thermal stability could expand what is feasible in larger vehicles, performance cars, utility vehicles, and demanding driving applications. For years, there has been a persistent tension in EV adoption between what works beautifully in passenger commuting and what becomes harder in heavier, harsher, or more specialized scenarios. A better motor does not solve every challenge, but it strengthens the foundation for attacking those categories. That alone could expand Tesla's strategic reach. A particularly important consequence would be the changing relationship between battery size and user experience. Much of the EV industry has leaned on bigger batteries as a solution to performance and range anxiety. But larger battery packs bring cost, weight, charging time concerns, and material intensity. A more efficient motor changes the logic. It allows more to be done with less. A Tesla motor reveal signals not only a hardware leap, but a potential systems-level lead. If Tesla can coordinate the motor with every surrounding layer more effectively than rivals, then competitors may find that copying isolated features yields disappointing results. The advantage may be emergent rather than modular, which makes it harder to close. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on Elon Musk's new Tesla EV motor? We want to hear from you. Thank you for watching, and see you next time.